In metallurgy, stainless steel, also known as inox steel or inox from French inoxidable, is defined as a steel alloy with a minimum of 10.5 or 11% chromium content by mass. Stainless steel does not corrode, rust or stain with water as ordinary steel does. But despite the name, it is not fully stain-proof. It is also called corrosion-resistant steel or CRES when the alloy type and grade are not detailed, particularly in the aviation industry. There are different grades and surface finishes of stainless steel to suit the environment the alloy must endure. High oxidation resistance in air at ambient temperature is normally achieved with additions of a minimum of 13% by weight, chromium, and up to 26% is used for harsh environments. The chromium forms a passivation layer of chromium oxide. When exposed to oxygen, the layer is too thin to be visible, and the metal remains lustrous. The layer is impervious to water and air, protecting the metal beneath. Also, this layer quickly reforms when the surface is scratched. This phenomenon is called passivation and is seen in other metals, such as aluminium and titanium. Corrosion resistance can be adversely affected if the component is used in a non-oxygenated environment. A typical example being underwater keel bolts buried in timber. When stainless steel parts such as nuts and bolts are forced together, the oxide layer can be scraped off, causing the parts to weld together. When disassembled, the welded material may be torn and pitted, an effect known as galling. This destructive galling can be best avoided by the use of dissimilar materials for the parts forced together. For example, bronze and stainless steel, or even different types of stainless steels, martensitic against austenitic, when metal to metal wear is a concern. Nitronic alloys reduce the tendency to gall through selective alloying with manganese and nitrogen. Additionally, threaded joints may be lubricated to prevent galling. Ferritic and martensitic stainless steels are magnetic. Austenitic stainless steels are non-magnetic. There are different types of stainless steels. When nickel is added, for instance, the austenite structure of iron is stabilized. This crystal structure makes such steels virtually non-magnetic and less brittle at low temperatures. For greater hardness and strength, more carbon is added. With proper heat treatment, these razor blade steels are used for such things as razor blades, cutlery, and tools. Significant quantities of manganese have been used in many stainless steel compositions. Manganese preserves an austenitic structure in the steel, similar to nickel, but at a lower cost.